So far, we've looked only at arrays and objects that contain simple types like numbers and strings. But there's nothing stopping you from using another array or object as a value in an array or object. For example, an array of dinosaur objects might look like this. var dinosaurs equals name Tyrannosaurus rex, period late Cretaceous. Name Stegosaurus, period late Jurassic. Name Plateosaurus, period Triassic. To get all the information about the first dinosaur, you can use the same technique we used before, entering the index in square brackets. Dinosaurs 0. Name Tyrannosaurus rex, period. Late Cretaceous. If you want to get only the name of the first dinosaur, you can just add the object key in square brackets after the array index. Dinosaurs 0 name Tyrannosaurus rex. Or, you can use dot notation, like this. Dinosaurs 1 dot period. Late Jurassic. Note you can use dot notation only with objects, not with arrays. Also contains an array. First, we'll make the objects, and then we can put them all into an array. Var Anna equals name Anna, age 11, lucky numbers 2, 4, 8, 16. Var Dave equals name Dave, age 5, lucky numbers 3, 9, 40. Var Kate equals name Kate, age 9, lucky numbers 1, 2, 3. First, we make 3 objects and save them into variables called Anna, Dave, and Kate. Each object has 3 keys: name, age, and lucky numbers. Each name key has a string value assigned to it, each age key has a single number value assigned to it, and each lucky numbers key has an array assigned to it, containing a few different numbers. Next we'll make an array of our friends. Var friends equals Anna, Dave, Kate. Now we have an array saved to the variable friends with 3 elements: Anna, Dave, and Kate, which each refer to objects. You can retrieve one of these objects using its index in the array. Friends 1. Name Dave, age 5, lucky numbers. Array 3. This retrieves the second object in the array, Dave. At index 1. Chrome prints out array 3. For the lucky numbers array, which is just its way of saying, this is a 3-element array. You can use Chrome to see what's in that array. See exploring objects in the console. We can also retrieve a value within an object by entering the index of the object in square brackets followed by the key we want. Friends2.name Kate. This code asks for the element at index 2, which is the variable named Kate, and then asks for the property in that object under the key name, which is Kate. We could even retrieve a value from an array that's inside one of the objects inside the friends array, like so. Friends0.luckynumbers1. For figure 4-2 shows each index. F. Friends 0 is the element at index 0 in the friends array, which is the object Anna. F. Friends 0.luckynumbers is the array 2, 4, 8, 16 from the object called Anna. Finally, friends 0.luckynumbers1 is index 1 in that array, which is the number value 4. Figure 4-2. Accessing nested values. Chrome will let you dig into objects that you print out in the console. For example, if you type Friends1, Chrome will display the output shown in Figure 4-3. Figure 4-3. H. How an object is displayed in the Chrome interpreter. The triangle on the left means that this object can be expanded. See. Click the object to expand it, and you'll see what's shown in Figure 4-4. Figure 4-4. Expanding the object. You can expand lucky numbers. 2. By clicking it, see Figure 4-5. Figure 4-5. EXP. Adding an array within the object. Don't worry about those properties, they have to do with the object's prototype. We will look at prototypes later, in Chapter 12. Also, you'll notice that the interpreter shows the value of the array's length property. You can also view the entire friends array and expand each element in the array, as shown in Figure 46. Figure 4-6. All three objects from the friends array, as shown in the Chrome interpreter. Now that you know a few different ways to create objects and add properties to them, let's put what we've learned to use by trying out some simple programs. Keep track of how much money each of them owes you. You can use an object as a way of linking a string and a value together. In this case, the string would be your friend's name, and the value would be the amount of money he or she owes you. Let's have a look. var owed money equals owed money Jimmy equals 5. Owed money Anna equals 7. Owed money Jimmy 5. Owed money Jinan. Undefined at, we create a new empty object called owed money. At, we assign the value 5 to the key Jimmy. We do the same thing at, assigning the value 7 to the key Anna. At, we ask for the value associated with the key Jimmy, which is 5. Then at, we ask for the value associated with the key Jinan, which is undefined because we didn't set it. Now let's imagine that Jimmy borrows some more money, say, 3. We can update our object and add 3 to the amount Jimmy owes with the plus equals operator equals that you saw in Chapter 2. Owed money Jimmy equals 3. Owed money Jimmy 8. This is like saying owed money Jimmy equals owed money Jimmy 3. We can also look at the entire object to see how much money each friend owes us. Owed money Jimmy 8. Anna 7. Information about those movies on your computer so you can find out about each movie easily. You can create an object to store information about your movies, where every key is a movie title, and every value is another object containing information about the movie. Values in objects can be objects themselves. var movies equals Finding Nemo. Release date 2003, duration 100, actors Albert Brooks, Ellen DeGeneres, Alexander Gould, format DVD. Star Wars Episode 6, Return of the Jedi. Release date 1983, duration 134, actors Mark Hamill, Harrison Ford, Carrie Fisher, format DVD. Harry Potter and the Goblet of Fire. Release date 2005, duration 157, actors Daniel Radcliffe, Emma Watson, Rupert Grint, format Blu-ray. You might have noticed that I used quotes for the movie titles, the keys in the outer object, but not for the keys in the inner objects. That's because the movie titles need to have spaces, otherwise, I'd have to type each title like Star Wars episode if I return off the GD. And that's just silly. I didn't need quotes for the keys in the inner objects, so I left them off. It can make code look a bit cleaner when there aren't unnecessary punctuation marks in it. Now, when you want information about a movie, it's easy to find. var Finding Nemo equals movies Finding Nemo. Finding Nemo.duration. 100 Finding Nemo.format. DVD. Here we save the movie information about Finding Nemo into a variable called Finding Nemo. We can then look at the properties of this object like duration and format to find out about the movie. Here we create a new object of movie information about cars. We then insert this into the movies object, under the key cars. Now that you're building up your collection, you might want to find an easy way to list the names of all your movies. That's where object.keys comes in. Object.keys movies. Finding Nemo, Star Wars Episode 6, Return of the Jedi, Harry Potter and the Goblet of Fire, cars. Now you've seen how objects work in JavaScript. They are a lot like arrays, because you can use them to hold lots of pieces of information together in one unit. One major difference is that you use strings to access elements in an object and you use numbers to access elements in an array. For this reason, arrays are ordered, while objects are not. We'll be doing a lot more with objects in later chapters, once we've learned about more of JavaScript's features. In the next chapter, we'll look at conditionals and loops, which are both ways of adding structure to our programs to make them more powerful.